Good evening, Scott here, known as Cantaloupe to some online, and I'm bringing a video to you on a subject that's interesting to me. It might be of interest to you or someone you know. And I just watched a short for-profit video about supernovas, and it got me thinking. In the video, they said that astronomers still don't know exactly what causes supernovas, and I'm not sure that's entirely true. I think some people have a really good idea, and I have a good idea, and I just want to describe my impression or my understanding of what happens in that kind of cataclysmic explosion when a star finally dies, a star of sufficient magnitude. So for review, this might be review for some people, but a star of sufficient mass, when it dies, it may or may not do nova or supernova explosions. Our sun supposedly has insufficient mass to do either of these things. It will become a red giant at some point. It will just continue to expand and decrease in intensity, but it will never explode like a nova or a supernova star. But what happens is there is a sustained fusion reaction in any star, and depending on the amount of mass that the star has, the size of the star that is, it may or may not explode when it dies. So here's the thing that I think if people are confused, if astronomers are confused about what causes supernova explosions, it's because they haven't wrapped their heads around the actual energy of a sustained fusion reaction. It is extremely energetic to the point where it can push astronomical amounts of mass out from a gravity well that has the potential to be, in many cases, a singularity or a black hole, and would be if not for this reaction, this ongoing fusion reaction that presses the mass out from the center of it. So consider that this battle of forces between gravity and the extreme violence of an ongoing sustained fusion reaction is enough to create so much heat just from the forces fighting each other that you have the light and the heat of the stars themselves. And incidentally, due to this same battle, you have heat inside of the planets as well. It's not from when they formed, it's an ongoing process of gravity fighting the condensation of matter that is resisting the gravity and creating a type of heat from friction. It's gravitational friction, if you will. It's one way to look at it. So anyway, a supernova explosion, if you think about the types of material that are in young stars especially, they just grab up whatever's around, don't they? There's tons and tons of hydrogen and helium. We already know this from our own local solar system. Jupiter, our sun itself, fuses hydrogen into helium and heavier elements. And what happens, hydrogen happens to be the lightest element of all that we know of. It's atomic weight of 1, I think, if I understand it correctly. I'd have to review, but it's a very lightweight element. But when you have so much hydrogen in one place, astronomical amounts of it, just unbelievable amounts of hydrogen, it begins to form gravity, right? And then it condenses and it falls into a gravity well, so to speak, begins a chain reaction of fusion, a sustained ongoing fusion where it is built into helium and then successively denser elements as the star ages. So you have what ends up being, towards the end of the star's life, regardless of the size of the star, it will reach a point where it has built successive elements into heavier and heavier elements until the process just kind of fizzles out. It can't continue anymore because you cannot fuse beyond iron. To my knowledge, what I've heard is that no star can fuse iron, and once it develops a sufficiently massive core of unfusible iron, that's when the star ends its life, basically. So if you have a star that is sufficiently massive, it has just unbelievably large amounts of matter inside the star, fusing constantly, it will get to this point where some layer within that star, some very, very large and spacious layer that has been for millions or billions of years fusing in a sustained reaction, it has a cascading failure at some point when it finally exhausts its fuel and it's ready to move on to the next heavier element. The process may or may not continue at that point. When it gets to the point where there's an element like iron, or not necessarily iron, but something that cannot be fused anymore, it finally collapses. This gigantic space inside this star that is constantly under gravitational relativistic forces, like not just things that we are accustomed to on Earth, but forces of gravity that, like I said, without the fusion reaction, it would be a black hole with these kinds of stars. It collapses at relativistic speeds. So you end up with not just a failure of the fusion, but all of the matter that it was supporting, all of the lighter elements atop that layer of matter, which can be a number so large that you couldn't write it down easily. That much matter falls at near the speed of light towards this iron core in the middle. And when it strikes that core, because the fusion has failed, all of a sudden you end up with a rebound effect. So much heat and energy is released when these lighter elements strike that core at a relativistic speed that you end up with a supernova explosion. My understanding is that's how it works. So you have this gigantic nebulous explosion that just blasts outward, and you can see it from hundreds of millions of miles away. The brightest things that we can see in the universe, to my understanding. So that's how it goes, I think. In summary and in short, every star fuses lighter elements into heavier elements until at which point they cannot do it anymore. And if the star is sufficiently massive, it will collapse at a relativistic speed, creating a compression effect with so much heat, and it explodes back outward. So you can get a nova if it's a mid-range star, or if it's a super giant star, it will go supernova, which forms a nebula and all of the amazing structures that we can see with telescopes, high-powered telescopes. You can pick out these remnants, they call them, of supernova. Anyway, I'm not even an astronomer. It's just stuff that I picked up from watching PBS and whatnot. If you are interested in this stuff, reach out with questions or comments to whitehotrobot@gmail.com. Thank you.